Welcome to the Deep Dive, your shortcut to highly relevant practical expertise. If your professional role involves curriculum design, knowledge management, maybe institutional strategy, and you need the fastest, most efficient path to fluency in Google's generative AI world, well, this deep dive is specifically for you, the learner. Our mission today isn't just a summary. We're going deep, detailing the essential concepts right from the Google Gen AI Leader certification materials. So you walk away genuinely informed, ready to use this stuff.
Exactly. We're going beyond just definitions. We want to get into the so what for people making decisions. This credential, the GCP GAL, it gives you a framework, really, for understanding the strategy and the function of tools like Gemini, Vertex AI, Notebook LM. For you educators, trainers, content managers, this isn't just another cert. It's about learning the language, understanding where these tools fit both ethically and practically in your courses and your workflows.
And the context here is key, because the sources, they really position this as an easy win. It's concept-based. It's designed to check if you understand Google Cloud's Gen AI stuff, the products, the language, the limitations too. And crucially, you don't need to write Python or draw network diagrams. It's about strategy, not engineering.
Right. So let's break down the GCP GAL profile itself. It is a formal Google Cloud certification. It sits in their hierarchy. But unlike the ones for hardcore developers or engineers, this one leans heavily into, well, business strategy, foundational ideas, and how Google Cloud weaves Gen AI into its enterprise stuff. It's really about using the tech, not building it from scratch.
And the sources really hammer home the accessibility point. It's billed as the shortest, easiest Google Cloud cert out there. Costs about, what, $99 US?
Around that, yeah.
And the study time they recommend is tiny, maybe 5 hours if you're totally new to cloud.
Or even less, maybe 2 or 3 hours if you've already got some GCP basics down. Like if you did the Cloud Digital Leader first.
Okay, but hang on. If it's that easy, that cheap, does it actually mean anything? Why should, say, a school administrator or a curriculum lead spend even that $99?
That's a fair question, and the answer really boils down to signaling. The value isn't proving you're a tech wizard. We already said it doesn't do that. It's really two things for a professional. First, it guarantees a shared language, a common vocabulary. So if your IT team starts talking about RAG or few-shot prompting...
You're not lost. You know what they mean.
Exactly. And second, it's a signal to employers, to partners. It shows you're current on the enterprise Gen AI scene, that you've done your homework on the tools you might want to adopt or, fund. For someone managing how knowledge flows in an organization, this cert says, okay, I get the architecture, the risks, the benefits of Google's tools.
Okay, that makes more sense. It's an investment in being able to talk the talk, essentially, communication fluency. And speaking of who it's for, the core audience is explicitly not technical deep divers. We're talking solution architects, key business decision makers, and sales engineers translating tech into business value, which means, again, it doesn't test coding or system design, makes it accessible for leaders.
Precisely. If you're holding the purse strings for ed tech or you're designing PD for your training department, you need to grasp the product suite. You need the language, the limitations to make smart choices about buying and rolling things out. This credential gives you that big picture without demanding you become the AI engineer yourself.
So let's look at the exam itself, the blueprint. There are 4 main areas.
4 domains, yeah. First is fundamentals of Gen AI. That's our concept hierarchy we'll get into.
Okay.
Second, Google Cloud's Gen AI offering. So the specifics, Vertex AI, Gemini, the tools for developers.
Makes sense.
Third, improving the Gen AI model output. This covers things like accuracy, grounding, responsible AI use, really important stuff.
Crucial. And the last one.
And finally, business strategies for successful Gen AI solutions. So implementation, cost considerations, managing teams around this tech.
And the format is pretty standard, multiple choice.
Yep. Multiple choice, usually 50 to 60 questions. You get 90 minutes, so an hour and a half.
Passing score is 700 out of 1,000. So 70%.
That's the official pass mark, yes.
But I noticed the sources strongly advise aiming higher in practice, like 85%. Why shoot for 85 on an easy test? Seems like overkill.
It connects back to that non-technical focus. Because it's aimed at a business or strategic audience, the questions can sometimes be, worded trickily. They might use complex business jargon, long scenarios, maybe slightly ambiguous phrasing that kind of obscures the core technical concept.
You might know what AUG is called.
Exactly. You might understand ARG perfectly, but the question might phrase it as leveraging current knowledge bases to mitigate knowledge cutoff without full parameter update.
Okay, I see. The wording could trip you up even if you know the tech.
Precisely. So aiming for 85% in practice, just build a buffer. It ensures your understanding is solid enough to cut through any confusing language on the real exam.
All right, before we get into Google's specific tools, we need that shared vocabulary we mentioned. Let's unpack the AI hierarchy, starting broad and narrowing down to generative AI.
Okay. At the very top, the biggest umbrella is artificial intelligence, AI. This is the oldest idea, the big goal. Building machines that can do things normally needing human smarts. Things like learning, solving problems, understanding language. It's the whole field.
Got it. Level 2 down.
That's machine learning, ML. It's a subfield of AI. Here, machines learn specifically from data. Instead of programmers writing explicit rules for every situation, the machine figures out its own rules by spotting patterns in the data it's given. It gets better at a specific task over time.
Okay, AI, then ML learning from data. Inside ML.
Inside ML, you get deep learning, DL. This is a specific approach within ML. It uses complex structures called artificial neural networks. Think of them as having many, many layers, sometimes hundreds. These deep networks are amazing at finding really complex, subtle patterns in huge amounts of messy data, like recognizing faces in photos or understanding the nuances in speech.
And that brings us to the main event, generative AI, Gen AI.
Exactly. This is a specific application of ML, often using deep learning. While a lot of traditional AI is about analyzing data, classifying an email, predicting a trend, Gen AI is about creating something new.
Creating.
Yeah, generating novel content, text, images, music, code, video, stuff that didn't exist before based on what it learned.
And this creation relies on specific kinds of models.
It does. The foundation, quite literally, are foundation models. These are enormous ML models, trained on just unbelievable amounts of unlabeled data. Think like huge chunks of the internet. This incredibly broad training gives them a really deep understanding of language, context, how things relate. It makes them super adaptable to many different tasks, not just one specialized thing.
And the type of foundation model we hear about most is the large language model, LLM.
Right. That's a foundation model specifically honed for understanding and generating human language. Text, basically.
And the breakthrough tech there was the transformer architecture, wasn't it?
Absolutely. Transformers were a game changer. Before them, models really struggled to keep track of context over long sentences or paragraphs. The transformer lets the model weigh how relevant every other word in a sequence is when it's processing just one word. That unlocked this deep understanding of context that powers models like, well, Gemini.
Okay, one more term here. Modality. What's that about?
Modality is just the type of data a model works with. Text is one modality, images are another, audio, video, code, those are all modalities.
So a model can handle different types.
Yes, and that's where it gets interesting. Modern models are often multimodal. They can handle, understand, and even generate multiple types of data at once. You could feed it text and a picture, and it might spit out a description, maybe generate a related audio clip. It processes across modalities.
Okay, let's switch gears slightly. Still foundational, but looking at how these models learn. The three main approaches of machine learning. Vital for curriculum, right?
Definitely vital. The first one, and probably the most common, is supervised learning. Here, the model trains on labeled data. That means every piece of input data comes with the correct answer, the label.
Like grading essays.
Perfect example. You want an AI to grade student essays. You feed it thousands of essays, that's the input, but each essay already has a grade given by a human expert, like pass or needs work, that's the label. The model learns the pattern that connects the essay text to the correct grade label.
So learning from known answers. What's next?
Next is unsupervised learning. You use this when you have a ton of data, but it's unlabeled. You don't have the right answers beforehand. The goal here is for the algorithm itself to find interesting structures or natural clusters or hidden patterns within the data without being told what to look for.
Can you give an example?
Sure. Imagine a university looking at student engagement data from online courses, clicks, forum posts, video views, but all anonymized. No grades attached. Unsupervised learning could analyze all that activity and maybe discover distinct groups of students, like a group that watches all the videos but never posts in forums, or another group highly active in discussions but with low completion rates. These groups emerge naturally from the data.
Okay, supervised needs labels, unsupervised finds patterns in unlabeled data. What's the third one?
The third is reinforcement learning. RL. This one's different. It learns through trial and error, interacting with an environment. It gets feedback in the form of rewards for good actions and penalties for bad ones, trying to maximize its total reward over time. It's learning by doing, basically.
Like training a dog, almost.
Kind of. The source material often uses the example of an AI robot learning the best routes to deliver packages in a city. Its goal is efficient delivery. It gets positive points, rewards for fast deliveries, negative points, penalties for getting stuck or taking too long. Through thousands of virtual deliveries, constantly adjusting based on those points, it figures out the optimal routes, often finding paths a human wouldn't have thought of. No pre-labeled maps needed, just the reward signal. Hashtag #tag3, practical Gen AI tools for the educator's toolkit.
Okay, foundations covered. Now let's get practical. Tools that educators, knowledge managers, people like you listening can actually use. Starting with Notebook LM. Sounds powerful.
Oh, it really is. Notebook LM tackles a huge problem: information overload and verifying where AI gets its answers. It's designed from the ground up as an AI-first notebook. But here's the key. It is entirely grounded in the documents you upload.
Only my stuff.
Only your stuff.
Yeah.
You feed it PDFs of research, policy docs, lecture slides, even YouTube transcripts. Then when you ask it questions, ask for summaries, ask for connections, its answers come only from that material.
Wow. Okay, for a researcher or a teacher designing a course, that's huge for efficiency and integrity, right?
Absolutely. Imagine uploading, say, 20 key research papers for a course module. You can then ask Notebook LM, summarize the main arguments against author X's theory, citing sources, or create flashcards for the key terms in these documents, or even explain concept Y as if you were talking to a high school student.
And it cites its sources within my documents.
Directly. It provides citations back to the specific passages in your uploaded material, which is fantastic for teaching students proper referencing and, frankly, avoiding accidental plagiarism. And it goes beyond just Q&A and summaries. The sources mention it can generate all sorts of learning aids directly from your materials. Things like detailed reports, quizzes based only on the readings, mind maps for visual folks.
Mind maps.
Nice. Yeah. And even AI-generated audio summaries, like a mini podcast recapping the core ideas from your uploaded syllabus and readings. All custom, all grounded.
That's really personalized learning support. Okay, moving to the main AI app, Gemini. How does that fit in?
The standard Gemini app is more your quick turnaround content helper. Good for brainstorming ideas, drafting emails, getting a first pass at a presentation outline, summarizing meeting notes, that kind of thing. Quick content creation.
But there's a customization angle too, right?
Yeah.
With gems.
Yes. Gems are like building your own little specialized AI assistants within Gemini. Think custom GPTs, but in the Google ecosystem. This is where an educator can get really specific. Let's say you're teaching Japanese. You could create a Japanese N5 grammar bot gem.
Oh.
You'd upload only the official N5 level textbooks and maybe some specific practice exercises. Then you instruct the gem. Act as a friendly tutor. Only answer questions based on these N5 materials. Don't discuss N4 or anything else.
So students get targeted, reliable practice within set boundaries.
Exactly. Consistent, context-specific help based only on the curriculum you've defined for it.
Okay, let's scale that up. For a whole university or a big training department, managing internal knowledge is messy. That's where Gemini Enterprise comes in.
That's the idea. Gemini Enterprise is designed to help large teams make sense of their own scattered internal information. Think beyond just public web knowledge. Take a university's accreditation process. The information they need is probably spread across legal docs, department policies, student record systems, financial reports, HR databases, everywhere.
A nightmare to search manually.
Totally. Instead of staff spending weeks digging through all that, you could create a custom Gemini Enterprise agent. That agent could be given access to securely tap into all those different internal systems, understand the context, and answer complex compliance questions by synthesizing information from across the board. Huge time saver for admin.
Right. Now, for the creative side, making stuff, we have Imagen.
Imagen is Google's powerhouse for text-to-image. You type in a description, and it generates an image. For educators creating course materials or designers needing visuals, Imagen is great for generating high-quality, often photorealistic images quickly. Custom illustrations, mock-ups for projects, visual aids, without needing a photographer or graphic designer for every little thing.
And for moving pictures, Veo.
Veo is the counterpart for video generation. Feed it text or even a still image, and it can generate video content. An instructional designer might use it to create short, dynamic video explanations of a concept, maybe personalized for different learning styles.
But there's a catch with Veo, isn't there? Something about data.
Yes, and this is a key distinction, often tested. Veo works from static inputs, a text prompt, an uploaded image. It cannot currently process and visualize live, changing data streams.
So no generating a video showing real-time stock fluctuations or live weather patterns.
Correct. It needs that fixed starting point, the text or the image, to generate the video. It doesn't dynamically update based on incoming live data. #TagIV. Improving accuracy and responsible AI use.
Okay, we have these amazing tools, but we absolutely have to talk about the biggest challenge: accuracy. Or rather, inaccuracy. These models aren't perfect.
Far from it. And managing those imperfections is critical for professional or academic use. The number one issue is hallucinations.
Hallucinations. Sounds dramatic.
It is. It's when the model just makes stuff up. It generates outputs that sound plausible, are grammatically perfect, but are factually wrong or totally fabricated. And the scary part is, it delivers these fabrications with the same apparent confidence as it delivers facts.
Like that example of it inventing revenue figures for a company.
Exactly. Generating fake press releases, non-existent features, confidently incorrect information.
Then there's a knowledge cutoff. That seems pretty straightforward.
It is, but it has huge implications. The models only know information up to the date their training data ended. Ask about anything that happened after that date, a new law, a scientific discovery, or crucially for organizations, a new internal policy, and the model simply won't know. It might guess or give you the old, outdated information.
And the third big challenge: bias and fairness.
A major one. These models learn from vast amounts of real-world text and data, and that real-world data, well, it reflects historical and societal biases.
So the AI picks up those biases.
It can, yes, and sometimes it can even amplify them. This can lead to unfair or skewed outcomes, especially if the AI is used in sensitive areas like hiring, loan applications, or even student evaluation.
Okay, problems identified. Hallucinations, knowledge cutoff, bias. How do we fix them? Or at least manage them? The core idea seems to be grounding.
Grounding is the key technique. It means connecting the AI's output back to verifiable, authoritative information sources. Instead of letting the AI only rely on its internal, vast, but potentially flawed or outdated knowledge.
You make it check its facts first.
Essentially, yes. You force it to consult specific, trusted sources before it generates an answer. This could be Google search for current events, an official company knowledge base for policies, a specific database for scientific facts. It dramatically boosts accuracy and makes the output more reliable because it's tied to a real source.
And this is where retrieval augmented generation comes in, RG. Did I say that right? Sounds like.
Exactly like the cloth you clean with. RAG. And it's the practical solution, especially for that knowledge cutoff problem. Because fully retraining a massive LLM every time a policy changes or new information comes out is incredibly expensive and slow. It takes massive computing power, months of work.
Impractical for most organizations.
Totally. RE gets around this. Think of it like giving the LLM temporary notes. When asked a question, the RE system first goes and retrieves relevant, up-to-date information from an external source you specify, like that new policy document.
Okay.
Then it feeds that retrieved current information to the LLM as context, along with the original question. The LLM uses this fresh context to generate its answer.
So the element itself doesn't need retraining. It just uses the info RE fetches right now.
Precisely. The model stays the same, but its effective knowledge is instantly updated for that specific query by pulling from the live authoritative source. It's much faster, much cheaper.
So if my internal HR bot is citing an old version of the employee handbook,
RAG is how you fix it. You point the RAG system to the current handbook location. Problem solved, no massive retraining needed. And Google Cloud has Vertex AI Search, which basically works as an out-of-the-box RAG system for enterprise data.
Okay, RAG for accuracy. But what about responsibility, particularly explainability and transparency? If an AI denies someone a spot or flags a student paper, you need to know why, right?
Absolutely. Just getting an answer isn't enough for high-stakes decisions. Saying the AI said no is unacceptable.
So the sources talk about implementing explainable Gen AI policies.
Yes. It's about building systems where you can understand the why. You need to be able to audit the process to see which factors, which data points the AI weighted heavily in making its recommendation or decision. This transparency is essential for building trust, for debugging, and crucially, for identifying and mitigating bias.
And for really sensitive areas, student data, finance, healthcare, we still need people involved, humans in the loop.
Definitely. HITL isn't just a good idea, it's often a requirement. It means building formal checkpoints where a human reviews, validates, or corrects the AI's output or decision. This ensures content moderation is appropriate, Accuracy is double-checked where it matters most, and ultimately, a human remains accountable for critical actions taken based on the AI's suggestion.
Okay, we know the models, the tools, the safeguards. But getting the best out of them depends on how we interact with them. That's prompt engineering, right?
Exactly. The prompt is your steering wheel for the LLM. Knowing how to craft effective prompts is the difference between getting generic fluff and getting genuinely useful, tailored output. It's a critical skill. The simplest approach is zero-shot prompting. You just ask the model to do something without giving it any examples.
Like summarize this article.
Precisely. It relies entirely on the general knowledge baked into it during training.
But we can give it examples. That's few-shot prompting.
Right. Also called in-context learning. This is really powerful when you need a specific format or style. You provide a few examples of the shots within the prompt itself to show the model what you want.
So if I want quiz questions written in a certain pedagogical style,
you give it 2 or 3 examples of questions already written in that style in the prompt. Then you ask it to generate a new one. It learns the pattern from your examples.
that makes sense. What about role prompting?
Super useful and easy. You just tell the model who it should be, assign it a persona.
Act as.
Act as a skeptical editor. You are a patient high school physics tutor. Respond as an expert in 18th century French literature. Giving it a role influences its tone, the vocabulary it uses, its perspective, makes the output much more focused and appropriate for your task.
Okay, and then there's the one that sounds really interesting for complex tasks. Chain of thought prompting, CODE.
CODE is about getting the model to show its work. Instead of just jumping to an answer, you specifically instruct it to reason step by step.
You literally say, think step by step.
Often, yes. Something like, solve this problem step by step, explaining your reasoning at each stage. Why does this work? Well, if you think about human cognition, there's fast, intuitive thinking system 1 and slow, deliberate, logical reasoning system 2. COTE essentially pushes the LLM toward system 2 thinking. By forcing it to break down the problem and articulate the intermediate steps, it significantly improves accuracy, especially on complex reasoning tasks, math problems, logic puzzles, analyzing complex scenarios, essential for anything needing a verifiable, logical conclusion.
Okay, so prompting controls the what and the how. What about controlling the outputs vibe? It's creativity or randomness, that's sampling parameters.
Exactly. These are knobs you can tune. The most common one is temperature.
Temperature, like heat.
Sort of. It controls the randomness of the word selection. A low temperature, close to 0, makes the output very predictable, very deterministic. The model almost always picks the statistically most likely next word.
Good for facts. Quizzes, code.
Perfect for those. When you need consistency and correctness. But if you turn the temperature up, the model takes more chances, considers less likely words. The output becomes more creative, diverse, maybe even surprising.
Better for brainstorming, writing stories, generating different options.
Exactly. High temperature for creativity, low temperature for precision.
What else can we control? Output length.
Yes. Token count or maximum output length. Tokens are the pieces of text the model processes, roughly words or parts of words. Limiting the token count is important for practical reasons. It affects how much memory the model uses, how much the query costs, often you pay per token, and how long it takes to get a response. So setting a max length is often necessary, especially in applications.
Okay, and one more parameter mentioned was top P, or nucleus sampling.
Top P is another way to control randomness, a bit more nuanced than just temperature. Instead of considering all possible next words with adjusted probabilities, like temperature does, Top P tells the model consider only the most probable words that add up to a certain cumulative probability threshold.
Huh. Can you simplify that?
Sure. Imagine the model has calculated the probability for every possible next word. If you set top P to, say, 0.9 or 90%, the model looks at the most likely word, then the next most likely, and so on, adding up their probabilities until it hits 90%. It then only chooses its next word from that smaller group, the nucleus of most likely candidates. It ignores the really improbable words entirely. It's a way to get variety without going completely off the rails. #outro. So wrapping this all up, what should you, the learner, the educator, the knowledge manager, take away? I think you now have a really solid strategic map. We went from the certification itself, easy entry, high value for signaling and vocabulary, all the way to practical tools like Notebook LM for grounded research and RA, Remember Red Har, for keeping information current without costly retraining. You understand the concepts, the tools, and importantly, the ways to manage accuracy and use AI responsibly in your context.
Yeah, and I think the key insight, especially for this audience, is that the value isn't necessarily in becoming a deep AI technician. It's about deployment fluency. It's knowing which tool to use when. How to use Notebook LM right now to generate flashcards from your syllabus. How to set up gems for specific student practice. How to use RAG to ensure your training materials always reflect the latest compliance updates. That immediate practical application is where the power lies for professionals.
We talked about different kinds of AI agents, right? Deterministic agents that follow strict rules, good for reliable, repeatable tasks, and generative agents, powered by LLMs, bringing that creativity and complex reasoning. But the sources suggest the real cutting edge right now is in hybrid agents. These blend the strengths of both. The reasoning power of LLMs combined with trusted, predefined rules, tools, and data sources. You get flexibility and reliability.
Which brings us to our final thought for you to mull over. Thinking about those hybrid agents. What's the most complex, maybe high-stakes, multi-step process in your professional world? Something that currently relies heavily on human judgment, checks, maybe tedious manual steps. Could be curriculum approval, detailed student assessment analysis, maybe ensuring regulatory compliance. Could that process be effectively, safely, and ethically improved or even partially automated by a hybrid agent? One that uses AI's generative power for the complex parts, but follows strict, verifiable rules for the critical checkpoints. Think about that blend creative generation guided by trusted logic. How could it change how you work?